Yeah,
All
makes
right.
it easier to remember.
Well, it does. For some reason, it does. What kind of picture is this?
Oh, it was on the classroom board, like in class.
Whose hair is that?
Oh, that's a girl that was sitting in the front. I sit in the very back, and she happened to
Oh,
kind of get in it
so
by
you just
mistake.
took a picture.
Mm-hmm.
Okay.
Yeah, he put the problems up on the board. This is from a couple days ago. He said he'd give us a couple days to do it. I totally forgot that we had it. So
Okay.
yeah, I guess we could do this tonight.
Well, let's look at the first one.
Cool.
Well, this first one's actually tough.
Mm-hmm.
The reason is because the degree in the numerator is greater than the degree in the denominator.
Okay.
Okay? And you see why? We got an x squared in the numerator and we only have an x in the denominator.
Mm-hmm.
Whenever that is the case,
Uh-huh.
you have to actually do the division and you're going to have a slant asymptote. In other words,
Okay.
there's three different kinds of asymptotes. There's vertical, there's horizontal, and there's
Mm-hmm.
slant. Now,
Okay.
they don't mention the slant one here. They talk about vertical and horizontal
Mm-hmm.
and the domain, but then when they say graph, well, you have to know that it's a slant asymptote to graph that. Because a slant asymptote looks different than a vertical or a horizontal.
Okay.
So I'm reluctant to start with this problem.
Okay.
Come back to this problem.
Sure.
Don't think that's a good problem to start with. I'm trying to figure out why they would possibly start you with that.
Yeah, I know, it's kind of weird.
It is kind of weird. You know me, I'm a firm believer in going easy to hard.
Uh-huh.
So let's look at this one.
Okay.
To me, this is much easier.
Mm-hmm.
Mainly because the degree in the denominator is greater than the degree in the numerator. So
Okay.
first of all, are there any vertical asymptotes?
That would be X.
Anything that makes the denominator 0.
Oh, okay. So yeah, it would be X plus 4, then X plus 2.
Nope.
So,
Nope.
or so.
Nope. Nope. Notice one thing about the denominator.
Mm-hmm.
That's always a positive number.
Okay.
I'm adding a positive number to that. Can that ever be 0?
No.
No, it can't.
Uh-oh.
So, there is none.
Okay.
No vertical asymptotes. Vertical asymptotes only come when the denominator is equal to 0. Now, let's just make sure you understand how I solve that. In other words, this is what you would normally do. Set the denominator equal to 0. Well, that makes x squared equal to minus 8. Now if I take the square root of both sides, I'm taking the square root of a negative number.
Okay.
Can't do that. So
No.
that's why x squared plus 8 is never 0. It's always a positive number. So we don't have to worry about dividing by a negative number. How about the horizontal asymptote?
And the horizontal. So to find the horizontal asymptote, you do. How would you do that again? It would be.
There are only two cases, Dylan.
Okay.
That's where the numerator is the same degree as the denominator, in which case the horizontal asymptote is the ratio of their coefficients. In other words, if I had something like this. What's the horizontal asymptote for that?
The 2. Would it be 2?
3 over 2.
Oh, 3 over 2.
The
Okay.
ratio of their coefficients. That's the coefficient. That's the coefficient.
Oh, okay. So it would just be -1?
No. Oh, in our case, hold on.
In our,
I'm getting there. That's the first scenario.
Okay.
When the highest degree in the numerator is the same as the highest degree in the denominator, then it's the ratio of the coefficients. If the degree in the numerator is less than the degree in the denominator, it's always y equals 0. So that's it. There's really only 2 cases.
Okay.
That's where the numerator is equal, and it's where the numerator is less.
Okay.
The third case is question 26, where the numerator is exactly 1 greater than the denominator.
Mm-hmm.
In that case, you have to actually do the division, and you end up with a slant asymptote.
Weird. Okay.
Or what would be called an oblique asymptote.
Okay.
Have you dealt with oblique asymptotes?
Nope. We haven't talked about that yet.
What is that problem doing on here then?
That's a good question.
Well,
yeah.
And there's no other problem like that. Yeah, 31's like that.
Yep, 31 is.
That's it. No, 36 is also.
30.
So you have 3 problems that are like that. Mm-hmm. And we'll go over that, but all in good time. Let's do the ones that do not involve oblique asymptotes first.
Okay.
Okay, this is one of them. So the denominator, bigger degree than the numerator. The numerator is x to the 0, right?
Right.
Okay, the denominator is x squared. So that's my horizontal asymptote, always.
Okay.
As long as the denominator is a higher degree than the numerator.
Okay, and then it's always 0. Okay.
Then it's always y equals 0. Well, that
makes sense.
Be a pretty good way to do this.
Yeah.
In other words, I don't have a vertical asymptote.
Nope.
All I got is a horizontal asymptote at y equals 0, and I've drawn it.
Right.
Now, what are the X-intercepts?
Okay.
Start with the very first thing. Identify X-intercepts. What does y equal when you're talking about the X-intercept?
-24.
Nope, 0.
Oh, that's it. Okay.
Think about it. If I'm on the x-axis, y is 0, is it not?
Mm-hmm.
Doesn't matter whether I'm there, over there, over there, over there. Wherever I'm at, y is 0.
Okay.
A huge thing to remember is that x-intercepts come when y is 0, y-intercepts come when x is 0.
Okay.
So, are there any x-intercepts here? In other words, is there a way to make y 0? Can I solve this equation?
No, I don't think so.
No, you can't. In other words, the only way a rational quotient is equal to 0 is if the numerator is equal to 0. And this numerator is -24, so there's no way it's equal to 0.
No,
so
that makes sense.
There are no x-intercepts. In other words, there's no possibility that y can be 0 here.
Okay.
Okay? So the x-intercepts are none.
Okay. Yep. And then the horizontal asymptote.
The next thing it wants, vertical asymptotes, none. Horizontal asymptote, y equals 0. Domain and the graph. Well, let's see. Any restrictions on the domain? Is there any number that x cannot be?
So x is an element of all real numbers. There's no, there's not.
Correct.
Mm-hmm.
So the domain is all real numbers.
Yep.
Now so all we have to do is figure out how to graph it.
Uh-huh.
Well, let's see. If x were 0, that'll give us the y-intercept, which is minus 3.
Okay.
So we know that when x is 0, the y-intercept is that.
Yep.
And we know we have a horizontal asymptote at y equals 0. So as x goes to positive infinity, this curve's got to get close to that horizontal asymptote. And you can see that it does. Make x 100, and you got minus 24 over 10,000.
Mm-hmm.
Make x 1,000,000, and you got minus 24 over 1,000,000 squared plus 8. So as x goes to the right, we approach the horizontal asymptote.
Okay.
And as x goes to the left, it's no different. In other words, you make x minus 10, and minus 10 squared is still 100.
Yep.
Still approach 0. So there's our graph. Just like
Okay. All right.
Okay.
Okay.
Let's do the next one, 28. This time I'm going to write it out so that I can expand my... All right. Oops, hold on. I think I got it wrong. Nope. Got it right.
That's right.
Vertical asymptote. Where's that happen?
In the denominator.
Okay. What makes the denominator 0?
None. Oh, right. Cool.
Horizontal asymptote.
X squared minus 4.
Look to the power of x.
X squared.
That's the highest power in the numerator. That's the highest power in the denominator. Therefore, where's the horizontal asymptote?
At 2.
At
Y equals 2.
The ratio of their coefficients. That coefficient is 1. That coefficient is 1.
So just 1.
1 over 1.
Cool.
So y equals 1.
Okay.
Okay. Now, that tells us quite a bit. See if we can graph it from that. We have no vertical asymptotes. A horizontal asymptote. And horizontal asymptote means that as the function goes to infinity, it's going to approach this horizontal asymptote. Well, how about X-intercepts? In other words, we'll go in the same order they went before. We got the vertical asymptote, we got the horizontal asymptote. How about X-intercepts?
So you would look at the numerator for that, right?
Exactly. What makes x squared minus 4 equal to 0? Well, that means x squared would be equal to 4. What's x?
X would be equal to 2.
Plus or minus?
Or plus. Okay. Yep. My bad.
Well, if I had a song for that, it'd be worth $1 million. I'm serious. 95% of my students miss this.
Really?
They leave out the plus or minus. The song,
because we talk about it. It's just like totally,
what I would make would sound something like, if you are solving an equation by taking the square root of both sides, begin your answer with the words plus or minus. That's all I need you to remember, is that.
Okay.
You're solving an equation by taking the square root of both sides.
Right.
So your
Okay.
answer has to be plus or minus 2.
That makes sense, yeah.
That means that I go through the x-axis there
Mm-hmm.
and there.
Gotcha.
Okay. Now, what is y when x is 0?
When x is 0, then y would have to be 1.
Plug in x 0 into that. What do you get?
-4/3.
That's what y is when x is 0.
Oh, okay, that's how you figure that out.
Yeah. In other
Okay.
words, when you're looking for the y-intercept, let x be 0. When you're looking
Okay.
for the x-intercept, let y be 0.
Mm-hmm.
Okay? So,
Okay.
I know the curve goes through there, goes through there, goes through there, and it approaches this horizontal asymptote. Almost has to do this. Can't do anything but that.
Gotcha.
So these asymptotes, x-intercepts, y-intercepts, all are kind of necessary in order to graph the curve.
Uh-huh.
Next one, let's do 29.
Sure.
Easier again. In other words, one of the few where they get easier.
Uh-huh.
Vertical asymptote.
Okay, so it'd be 9 again.
Vertical asymptote
Right.
comes where?
Denominator.
So here's the denominator. It's when that equals 0. That's where the vertical asymptote's going to come.
So x squared is equal to 1.
Okay, now solve that. Remember
X
the
equals
song?
You gotta square root that, right?
No. The song says that if you're ever solving an equation by taking the square root of both sides, begin your answer with the words plus or minus.
Okay, so plus or minus 1/2.
1.
It'd just be 1. I guess that's right. Yep.
It's 1 squared.
1. I was thinking that.
1 squared.
1.
Okay, that's why the answer is plus or minus 1.
Okay.
So I got 2 vertical asymptotes at x equal 1 and x equal minus 1. Well, that makes a huge difference. How about my horizontal? In other words, the last 2 problems, we didn't have any vertical asymptotes.
No.
What are my horizontal asymptotes?
And so our horizontal asymptotes would be, so would you set the numerator equal to 0?
No. This is where you compare the highest degree variable in the numerator with the highest degree variable in the denominator.
So 1 to 2. Because the 1 in the numerator, 1
The
and 2.
denominator is the bigger one. It's always y equals 0.
Cool.
That's always the case, as long as the denominator is bigger.
Okay. That makes it. I just gotta drill that in.
It's the ratio of the coefficients. That's it. There's only really those 2 situations.
Okay.
I'm going to talk about the third situation, because I don't think we should be yet.
Not yet.
But the only 2 situations you need to know are where they're equal and where the denominator is bigger. That's it.
Okay.
Okay?
Okay.
So, now that, I got a lot to graph here.
Yep.
I know.
We need to figure out our x-intercepts, right?
Well, let's first of all draw our vertical asymptotes and our horizontal asymptotes.
Okay.
That's big. That's the grid
Uh-huh.
that we're going to graph this thing by. Okay, now let's talk about x-intercepts. Starting from there, how do you figure the x-intercept? It's y is equal to what?
The coefficients.
No. X-intercept. What does that mean about y?
It has to be equal to 0.
Okay. So let that equal to 0. Now you got 0 equals this function. What does that mean? How am I going to get this function equal to 0? Numerator has to be 0.
Right.
Notice what I can do. If I set that equal to 0, I can multiply both sides by x squared minus 1. Well, now what I end up with is still 0 on the left equals 4x plus 1 on the right. So now solve that. What's x?
1/4.
Negative.
Minus 1/4.
Minus 1/4.
Okay.
So that's the only x-intercept.
Okay.
X
so
minus 1/4. That's minus 1. That's plus 1. Minus 1/4 is like right there.
So you always look at the numerator for the x-intercept?
Yes. Well, no. If I have a rational quotient equals 0, then you set the numerator equal to 0. That's the only way anything can be 0.
Okay.
Notice that if my numerator comes out to be a number, there's no frickin' way that y is 0. The only way y is 0 is if my numerator is 0. Has to be.
Okay.
So that's why I go to that step immediately.
Okay.
Okay? Now that gives me my x-intercept.
Yeah.
Now, they have not been asking for it, but what's the y-intercept? Because the y-intercept's pretty easy to solve for. What's the x value if we're talking about the y-intercept?
Just 4. 4 over 1.
Dylan,
because you just look at the...
Dylan, there's two facts you have to remember. The x-intercept comes when y is equal to 0. The y-intercept comes when x is equal to 0.
Right.
That's it.
Right.
Okay, so what's the x? What's the y-intercept?
X equals 0.
Okay, so plug in 0 for x and tell me what you get.
Oh, okay, so on the top you do, it'd be 0 plus 1, so 1. And then, so just 1. Because
-1. That's -1.
0 minus, oh, -1, yeah.
Okay.
1 over negative, okay.
That tells us we have a point there. In other words, now we have a lot of points. We have the x-intercept, we have the y-intercept. Now all we have to do is figure out what this curve looks like. And these can be a little strange, actually. If you look down in my lower right, I'm going to give you a couple of possible curves. One's going to look, in other words, it's still hyperbolic in nature. Okay, so I'm still inclined to do that.
Okay.
And then it does something in between the vertical asymptotes. Well, usually that something is that. Sometimes it does not go above the x-axis and it just turns around and comes back down. It's an inverted U.
Okay.
But in this case, because we can see that it goes through the x-axis, then it almost has to be something like that.
Okay.
Now, I could plot it in Wolfram Alpha and verify that it looks like that. But to be honest, I don't need to. And I'll tell you why. Here's something that's good to know. If you go from right to left, notice that going into that vertical asymptote, we're going up to plus infinity. On the other side of it, we come out from the bottom minus infinity. This part in between goes to plus infinity on that side of the asymptote. Comes out of it on the other side minus infinity.
Okay.
Kind of think of it like curved space. Einstein said that if you could go in a straight line eventually you would come back on yourself.
Mm-hmm.
That's the way the universe works. The universe is curved. Okay? Well, in this universe, if on one side of the asymptote you go to plus infinity, you come out at negative infinity on the other side.
Weird.
So,
Okay.
well, it's a little bit like Einstein's curved space.
Uh-huh.
In other words, it's not the same. I'm just kind of trying to give you a reference point for memorizing it. In other words, you don't have a lot of curves that look like this. Let's say I had vertical asymptotes there,
Mm-hmm.
and that. Curves don't look like that.
No.
Why? Because it goes to plus infinity and it comes out the other side at plus infinity.
Mm-hmm.
So that's not a standard way curves are going to look. The standard way curves might look might be that. In other words, it goes to plus infinity on the right side of that asymptote, comes out on the bottom at negative infinity, goes to negative infinity on the right side of that asymptote, comes out on the other side at plus infinity.
Oh, okay.
So good thing to remember that on each side of asymptotes, you tend to come out at the opposite infinity. And that's helpful when you're graphing these things, because a lot of times you don't know what to graph. In other words, it's tough to graph it, even if you have X-intercepts and Y-intercepts and asymptotes and horizontal asymptotes, it's still tough to figure out exactly what the graph's going to look like. But that's a good thing to remember.
Definitely.
On each side of the vertical asymptote, you're coming from the opposite infinity.
Okay.
Okay? It's pretty heady stuff.
That is. Yeah.
This is heady stuff. Don't quite understand why they never ask for the y-intercept, because that's critical. We could see that that's vital in graphing these things. All right. Bill, I will let you go.
Sounds good.
And I will talk to you next Monday night.
Okay. Thanks, Mr. Cowan.
All right. Bye-bye.